Hi everyone. Let's talk today about the HQ challenge number 14. Let's just get right down to it. What is the minimum input flow needed for a 60% T-bar when placed on a patient with an inspiratory flow of 24 liters per minute? So basically, what's the minimum flow to set on the flow meter to meet this patient's inspiratory needs? All right, so I usually talk about this two separate ways. So we've got the device, and then we've got the patient. Okay, this is designed to run as a high flow system, which means the device has to exceed the patient's inspiratory needs. All right, so we do the magic box. This is a 60% T-bar. We have to get the air to oxygen ratio. All right, this is a 1:1 air to oxygen ratio, and the patient has an inspiratory flow of 24 liters per minute. Here's how you get the minimal flow to set on the flow meter. You take the patient's inspiratory flow and you divide it by the total parts. So 1 and 1 is 2. 24 divided by 2 is 12 liters per minute. That is the minimum flow that we need to set on the flow meter to exactly meet the patient's inspiratory needs. So that way we can be certain that the patient is receiving 60%. All right, so let's transition this into another question. A patient on a 50% veni-mask becomes dyspneic with a simultaneous drop in their saturations from 94 to 89. What is the most appropriate initial response? So let me show you kind of what's going on. So let's say we set up this patient on a 50% veni-mask, and I'm going to just say this veni-mask is run at 10 liters per minute on the flow meter, okay? So when we do the air to oxygen ratio, this is going to come up to 1.7 to 1. All right, add those together, multiply by the flow on the flow meter. This means that 50%, so 27 liters per minute, that 50% is flowing up out of that mask at a speed of 27 liters per minute. And so we have to assume that when we set that up, it was right and the patient was satting 94%. All was well. Okay, they get dyspneic, meaning they're feeling short of breath. So when the patient feels short of breath, they start breathing faster and a little bit deeper, which increases their inspiratory flow. All right, that mask is only providing 27 liters per minute. If a person starts breathing, and I'm just throwing a number out here, 32 liters per minute, they have to get that extra flow from the atmosphere, and now they're diluting that 50% source, and their sats drop to 89. So the first thing you need to do with an air entrainment system, if they get short of breath, their sats drop, increase the input flow. Because if I can bring this total flow up where I meet or exceed the patient's inspiratory flow, they'll be receiving that precise FiO2. So hope this has helped. See you soon.